Hello, welcome to this Respi's Atari stuff video. I'm very happy with this external disk drive that is converted to a Geox drive. Thanks to the SD card I can easily transfer files from my PC to the ST. However, the external drive is always drive B for the ST. Therefore, it's not possible to boot from an external drive. Also, some ST programs only want to work with drive A. Now there are modifications that can turn the external drive into drive A. In this video we will see if we can implement that one on the Mega ST without any destruction to the system. I often thought about building this modification into my Mega ST. But that would have meant cutting off legs of ICs or desoldering them from the PCB and then bend the legs. And I always want to make as few irreversible changes as possible to existing systems, so they always can be turned to the original state. Well, I recently saw someone install the modification in a 1040 ST without touching any IC. Let's see if this is also possible in the Mega ST. Let's start by looking how the floppy drive knows whether it's drive A or B. For this purpose, a floppy drive connector contains a drive select signal. This indicates which drive is currently active. Therefore, there is a drive select signal for both drive A and drive B. So the drive E select signal goes to the first drive and the drive B select to the second drive. In old school PCs, this was done by reversing a portion of the cable. The reverse portion also contains a motor A and motor B signal. With the ST there's only one motor signal for both drives. That's why the motor of drive B also spins when you read something from drive A. Anyway, but with the ST we have drive A internally, so you have to connect drive B external. That's why the drive select signal for drive A goes to the internal drive and for drive B to the external drive. These drive select signals are generated on the ST by the Yamaha sound chip on pins 19 and 20. So if you want to make the external drive an A drive, then you have to invert the signals on pins 19 and 20. You can do this by removing the Yamaha chip from the ST and bending the pins 19 and 20 so they don't make any contact anymore with the socket. Then you connect a switch to those pins which connects the signals to the drives. But for this to happen, the Yamaha chip has to be socketed. Otherwise you have to desolder it and insert the socket yourself. And I don't want to do that, and I don't like bending IC legs either. I prefer a non-destructive solution. Now I recently saw a video from BW's TechnoShed. This shows jumper pads on an STFM board to switch the drive select on the external drive from B to drive A. We can connect a switch to those pads and leave the Yamaha chip IC in the ST. But does my Atari Mega ST also have those jumper pads? Here's the Mega ST schema. Are those jumpers here too? Here's the connection for the internal drive. And below that the connection for the external drive. We take a closer look at this. And here's the drive 1 select. And here the drive 0 select. The drive 0 select goes to the internal drive. And we also see tracks going to the external drive. And here we have also those jumpers connections. These drive selects come from the Yamaha sound chip on the other side of the diagram. Here, from pins 19 and 20. But what does those jumpers switch? W5 goes to pin 6 of the external drive connector. And from W1 it goes to pin 5. But what's connected to pin 5 and 6? Here we have the 14-pin DIN connector for the Atari ST floppy drives. Pin 5 is drive 0 select and pin 6 is drive 1 select. Aha, so pin 5 is the drive select for the first external drive and pin 6 is for the second external drive. Because you can connect two external drives to the ST using a daisy chain connection. You connect the first drive to the ST itself and the second drive to the daisy chain connector of the first drive. So inside the first drive, pin 6 of the incoming connector is connected to pin 5 of the outgoing connector. But what are they connected to by the jumpers? Both W1 and W5 have pads 2 and 3 connected together by default. The D0 select goes to both drive select of the internal drive and to W1. And here we have the D1 select, which goes to the other side of that jumper. So with the current jumper setting, D1 select goes via jumper W1 to pin 5 of the external drive. So then the first external drive becomes drive 1. So it's drive B. If we switch the jumper to between 2 and 3, the 0 select goes to pin 5 of the external drive connection. So then the first external drive becomes drive 0 or drive A. And what does W5 do then? With the default jumper setting, pad 2 is connected to the plus 5 volt with R111 in between. And that pad 2 goes to the pin 6 of the external drive connection, so to the second external drive. But if we switch that jumper, the second external drive is connected to D1 select. In that case, the second external drive becomes drive 1, so it's then drive B. So with W5, you switch the second external drive between disabled and drive B. To make it even clearer, I drawn the circuit here. And here we have the D1 select and the D0 select of the Yamaha sound chip. Below we have the internal drive, with its drive select. And here are the connections for the two external drives. With the drive select for drive 0 and drive 1. The drive select of the second external drive is connected to the plus 5 volts by default. If we switch the jumper of W5 from 3 to 1, it's then connected to D1 select. This jumper allows you to switch the second external drive from disabled to drive 1, so it becomes drive B. The first external drive defaults to D1 select and thus becomes drive B. If we switch the jumper from 3 to 1, it will be connected to D0 select. So this jumper allows us to switch the first external drive from drive B to drive A. However, the internal drive is always connected to D0 select, which therefore is always drive A. So if you want to make the external drive drive A, you have to disconnect the internal drive. Now we want to install a switch that switches both internal drive and the first external drive between A and B. That will be this double pole two-way switch. The bottom side will be connected to the drives and the top side to the drive select signals. We leave jumper W5 for the second drive as is, but the function of jumper W1 for the first external drive will be taken over by the switch. So we will remove that connection. Then we first make a connection between the two poles of the switch, but then just the other way around. If one drive is connected to D1, the other must be connected to D0. Then we start with D0, which is on pin 1 of the jumper W1. Then D1, which is on pin 3 of jumper W1. So this goes to D0 and this to D1. And here is just the other way around. So D1 and D0. This pin will switch the external drive. We leave the second external drive as it is disabled and the first external drive is here on pin 5. It's connected to pin 2 of the jumper W1. So we'll connect it to the second pole. This pole will switch the internal drive. That's connected to pin 1 of jumper W1. But we can't use this because that's also connected to D1 select. So we'll have to disconnect the connection to pin 1. Then we can connect the switch to the drive pin select of the internal drive. Now we have everything connected. Let's go through it again to make sure everything is correct. This switch is connected to the drive select switch on the internal drive. In this position it's connected to D0 select and becomes drive A. This switch is connected to the drive select switch of the first external drive. And in this position it's connected to D1 select and becomes drive B. Now I'm going to flip the switch. Then the internal drive is connected to D1 select and becomes drive B. And the external drive in this position goes via this route to D0 select and becomes drive A. Well, that seems all to be correct. But yeah, that's the theory. I'll test it in the Mega ST itself to see if it's the same in the practice. For this we'll open up the Mega ST. So the top is off, but the jumper is under this power supply. So I have to disconnect that too. I'll put it here. And then I'll zoom in where the sound chip is located. That's right here. Oh look, and here are the pads for those jumpers. Let's see if I can zoom in a bit more. There, now you can see them clearly. W5 and W1. Now I want to check if they are indeed connected as shown in the schematic. You never know, maybe there are different versions of the motherboard. We'll start with pin 1 of W1. This should be connected to the Yamaha sound chip. Here's pin 20. And indeed, there is a connection. And pin 2 shouldn't be connected, and yeah, that's correct. And then pin 3 should be connected to pin 19 of the chip. Oh, I don't measure anything here. Let's go back to the schematic. Here's pin 3 of W1. This is connected to pin 1 of W5 and it goes to the Yamaha sound chip. Oh, but wait a minute. There is a buffer in between. That's U79, that's an 7407. So I'll have to measure from there, from pin 3. Okay, here we go again. I'll take pin 1 of W5 now, that's connected to pin 3 of W1. And here is U79. And indeed, there's a connection to pin 3. And here is R111, which is connected to the plus 5 volts. That should be connected to the other side of the jumper. And that's correct. So the drive select of the second external drive is connected to the positive 5 volts here. That goes through this W5. And we leave it that way. But we are going to modify the W1. So here 2 should be connected to 3. And that's correct. And that also applies to W1. But we do need to disconnect this connection. And then we're still left with the connection from the drive select to the internal drive. It connects here to the drive with this connector. So we need to disconnect the drive select here. But I want to leave this cable intact. How can I disconnect pin 10 without damaging the cable? For this I ordered this male to female flat cable. Then I can disconnect pin 10 here. And then connect it to the switch. There's just one problem. When I connect the male connector to the floppy connector, it turns out it doesn't have any grip at all. So it's not a male connector, but an PCB connector to solder into an PCB. But that can be solved with this, an PCB header. This does fit on the connector. Of course, I still have to cut it to the right size. But if I solder this header to this cable, then it will fit. And if I disconnect pin 10 here, I can then make the connection to the switch from here. I bent pin 10 to this connector so we can tap it off here later. And I remove pin 10 from this pin header. This way it won't make any contact with the connector. Then we can now solder the pin header to the connector. I'll start at the corners. Now for the other side. Now all the pins are soldered. I'll check if they make a good connection. I'll check also if there is any contact with the neighboring pins. Then I can also attach a pin header to the wire of pin 10. That's it. Then I can attach a wire to that pin header, which goes to the switch. To ensure the solder joints don't make any contact with anything inside the Atari, I'll cover them with some electrical tape. But then, I made a huge mistake. This cable can't be used as an extension cable at all. This cable crosses the wire alternately. I've tried recrossing the ribbon cable before it goes into the connector. But I cannot get it to fit onto this connector again now that the pin header is in its place. And a radical change is needed. I removed the pin header from the connector and solder it directly to the wiring. And here I also disconnected pin 10 again. And I also covered this with electrical tape. It's not the prettiest solution, but as long as it works. Now we can attach the cable in the Atari ST. First I connect pin 10 to a loose wire. Then the rest can slide onto the floppy connector. But that's not easy. Because of all the soldering, not all the pins are straight anymore. Finally it's in. Now the other end can be attached to the floppy drive. I can fit the extra length of the flat cable under the drive. There, you cannot see anything of that anymore. Now we move on to the other connections. These are located here at W1. We turn over the board. Then we see the other side of W1 here. And there's also that connection between the pins 2 and 3, which we need to remove. I'm trying to scratch that off very carefully with a knife. I have to be careful because the connection to pin 10 is right next to it. And we want to leave that intact. Although I'm aiming at a non-destructive modification, I do have to remove something here. But yeah, that can be easily repaired later with a jumper. Okay, let's measure whether the connection is really gone. Yes, I'm no longer measuring a connection. So that worked. Now I can place a pin header at that location. But if I also put a connector on there, it will be too high to fit under the power supply. That's why I'm going to use an angled header. But that doesn't fit very well either, because the component next to it is in the way. So I'm going to see if I can bend it a bit. Well, it's bent a bit. Hopefully it fits now. Let's see if it's in deep enough. Oh, it's fine. Let me solder it in the right way. Well, it's a bit tight, but it fits. Now we just need to find a place for this switch. I don't want to drill a hole in the housing for it. But I still have that grill here where the fan used to be. It could go there somewhere. Then I run the wires through the fan openings. Now the wires are through the openings, we can solder them to the switch. Starting with the white wire. That one goes to the internal drive. So we connect it to the middle pin of one of the two switches. Next we take the black wire. That goes to the external drive. So it goes to the other middle pin. And now the red wire. This comes from the drive 0 select. I connect it to the pin connected to the internal drive with the current switch position. And then we have the yellow wire from the drive 1 select. This goes on the same side, but next to the switch of the external drive. Then the drive 0 and 1 select also need to go to the other side of the switch, but crossed over. I will do that with these wires. First the yellow one. And then the red one. Now the yellow wire crosses over to the other side. We do the same with the red wire. And this is how they are connected crosswise. I'm not gonna shrink the heat shrink tubing now because I first want to test it. So I have reconnected the ST and booted it up. In the internal drive I have a floppy disk with the first word. In the external drive I selected an image with the degasalit. By the way, in case if you're wondering what kind of high resolution this is thanks to the ATW800 board. I've made videos about that too, where you can see what you can do with that board. But I've now set the switch in the position that everything should work as before. So I'm now opening drive A. And there I see the contents of the first word floppy disk. Now I open drive B. And there we have degasalit. So that is indeed the external drive. I close it again for now. And then I flip the switch to the other position. Now I'm going to open drive A again. That should now be the external drive. And what do we see? Indeed, degasalit. We see the contents of the external drive at drive A. Now I also open drive B. And this is indeed first word, so the internal drive. Great, it works exactly as intended. Now we know everything is working, we can start shrinking the tubes. So, that's nice and tight. But now we still have to mount the switch somewhere. I actually want to make a small case for the switch. But for now I mount it somewhere here, against the fan grill. Then I can get to it well enough to switch it. I'll use these two ties to secure it. So, something like this. Well, that was a lot harder than I anticipated. But I'm glad I managed it without damaging the Mega ST. Now everything could be reversed without a trace. I'm also glad it worked first time, despite all the adjustments I had to make to the original plan. And now we have reached the end of this video. And it was another Atari ST video. But other Atari products will be covered as well in the future. It was more of a catch-up after ignoring the Atari ST for years. But at least I can now use the SD card reader as floppy drive A, because I really needed that for another project I'm working on. But you see that in one of the next videos. For now I say goodbye, and don't forget to click the like and subscribe buttons. That helps a small channel like this enormously. See you at the next Atari stuff video. Bye!